Bismillahirrahmanirrahim. Exercise 8.2, question number 1. Here we can have the data. And according to this data, we have drawn its diagram. AB is 6 centimeter, AC is 4 centimeter, angle A is 60, and we have to find BC. We have to find this BC. We have drawn a perpendicular over here, CD, so that we can have a right angle triangle over here. And as we get a right angle triangle, so we can apply cos theta over here, which is base over hypotenuse, and cos of 60 will be equal to base is AD in this triangle ADC, base is AD, and hypotenuse is AC. By putting the value of cos 61 by 2 and AD we have to find, AC is 4, so AD will be equivalent to 2 centimeter. So we will be using this value afterwards. So now according to theorem 8.2, we know that if we apply theorem 8.2 to this diagram, it will become BC square is equal to AC square plus AB square minus 2 into AB into AD. By putting all the values here, AC is 4, AB is 6, and AD is 2. By putting all these values and calculating all these values by adding and subtracting these, we get BC square is equal to 28. And by taking its square root, it will be 5.29 centimeter, which is its answer. Now we come to the next question, which is question number 2. And its data is here. According to this data, we have drawn its diagram. AB, this length AB is 6 centimeter. This length BC is 8 centimeter, and this whole length AC is 9 centimeter. And it is given to us that D is the midpoint of AC. So we have taken a D over here, and it is the midpoint of AC. So it means that whenever we will take the length AD, it will be equivalent to 9 by 2, which will be 4.5 centimeters. So we will be using this value afterwards. We have to find median BD in this question, right? So we will apply Apollonius theorem, theorem 8.3, and according to this diagram, the Apollonius theorem will be equivalent to AB square plus BC square is equal to 2AD square plus 2BD square. Now we will put all the values over here. AB is 6, BC is 8, AD is 4.5, and we have to find BD. By putting all the values and by taking their squares and by adding them and by subtracting 100 minus 40.5, we will get 59.5 by 2. And when we take the square root of 29.75, it comes up to be 5.45 centimeter. So its median is 5.45 centimeter. Now we come to question number 3. In this question, there is a parallelogram ABCD, and we have to prove that AC square plus BD square is equal to 2 into AB square plus 2 plus BC square. So we have taken a simple parallelogram, and we will apply Apollonius theorem to this parallelogram to its different parts. For example, if first of all we will apply theorem 8.3 to its part BAD. In this triangle BAD, we will apply Apollonius theorem, and it will be equivalent to AB square plus AD square is equal to 2OB square plus 2OA square. OB is the half of the third side, and OA is the median. So this equation number 1, we have formulated it. Now according to the same pattern, we will formulate all the other statements. Now in ABC triangle, we will formulate this statement as AB square plus BC square is equal to OC square plus 2OB square. Now OC is the half of third side, and OB is the median here in equation number 2. Similarly, in equation number 3, when we come to triangle BCD, the length of the two sides are BC and CD, so we will take the squares. BC square plus DC square, it will be equivalent to 2OD, which is the half of the third side, and OC, which is the median. And in theorem and in statement number 4, in triangle ACD, we have two lengths AC and AD. So we'll take their squares. CD square plus AD square will be equivalent to 2OA square plus OD square. OD is the median, and OA is the half of the third side, and we have taken its square. Now we will add the left hand side of all these 4 equations, and right hand side of all these equations will be added to the right hand side. So by adding all these, we get, now you can see AB. Here we have AB, and here again we have AB. So we will get 2AB square. Then we have BC and another BC. So we have 2 BC squares. Then we have CD and another CD. So we have 2 CD squares. Then we have AD and another AD. So we have 2 AD squares. And on the right hand sides, we have 2 OA square and 2 OA squares. We have 4 times OA square, 2 OB and 2 OB, 4 OB squares, 2 OC and 2 OC, 4 OC squares, and 2 OD and 2 OD, 4 OD squares. Right? Now we have taken 4 as common, and the rest is here. Now I can write this OA. Here you can see this OA. This OA is actually the half of AC. This is full AC, and this OA is half of it. So I'm writing it as AC divided by 2. Similarly, I'm writing OB as BD divided by 2. You can see OB, this is OB, and it is half of this full BD. Right. Similarly, I can write this OC as half of AC, and OD is half of BD. Now, AC square by 4, BD square by 4, AC square by 4, and BD square by 4. Now, we can see that we have taken 4 common from the denominator as well, and we have cancelled it, and we are left with the AC square plus BD square plus AC square plus BD square, and we have 2 times AC square and 2 times BD square. Again, we have taken 2 as common, and we have cancelled it with this 2, that was this 2, and we are left with this statement. And now I'm putting CD equivalent to AB, because in our parallelogram, the opposite sides are equal, and these opposite sides are CD and AB, and another 2 opposite sides are AD and BC. You can see in the diagram. So I'm putting CD equal to AB, and I'm putting AD equal to BC. So by doing so, we can get 2 times AB square and 2 times BC square. So that we have written over here, and on the right hand side we have AC square is equal to plus BC square. So we have proved that 2 times AB square plus 2 times BC square is equal to AC square plus BD square. So that's all with exercise 8.2. Thank you.